Hi everyone. Today we're going to be learning about eclipses. If you don't have your materials with you, you'll need your science notebook, a pencil, and some color pencils. I want you to pause the video and go find those. Once you're ready, unpause the video. For the rest of us, let's just jump right in. Going to start out with the bell ringer. And so here's some vocabulary from last week. I want you to number 1 to 6 in a margin of your notebook. And I want you to write the letter that you think goes with each of these vocabulary words. So if you'll take and pause the video when you finish, please unpause the video and we'll go over these together. Let's look at our Bellringer answers. So tides, of course, we talked about, is the daily rise and fall of the water in the oceans. And sometimes we have big tidal changes and sometimes those tidal changes are much smaller. So it's the rise and fall of the water in the oceans. So we have a spring tide and a neap tide. Remember, these are the two special tides that are caused by the moon and sun being either in alignment and pulling together or being out of alignment. A spring tide is where the moon is aligned with the sun and they pull together, which creates big changes. A neap tide is sort of the opposite of that. The sun and moon are out of alignment, the gravities pull against each other, and it creates smaller tidal changes. So causes of tides, not really a vocabulary word, but I do want you to remember that the causes of the tides are the pull of the moon's gravity on the water in the oceans. And then, of course, low and high tide. Low tide is the low tide, lowest water level reached by a falling tide, whereas a high tide is the highest water level reached by a rising tide. So we're talking about eclipses today. Let's take a look at some objectives. We need to know what generally is going to be causing an eclipse. What causes an eclipse, if you know what that is? You're going to need to be able to name and describe the two main parts of a shadow. Hint, hint. We want to be able to compare the causes of partial eclipses and total eclipses. We want to be able to draw the sun, earth, moon alignment during a lunar eclipse. And then we also need to be able to describe what the moon looks like during a total lunar eclipse. We need to be able to draw the sun, earth, moon alignment during a total solar eclipse and describe what the sun looks like during a solar eclipse. So let's jump right in here. So eclipses are going to be caused when one object in space moves into the shadow of another object. My hope is that many of you remember the eclipse that we experienced almost a couple of years ago now, where during the middle of the day, we were able to go outside and at totality, when the eclipse was at its fullest, the sun mostly disappeared. Hopefully you had some special glasses on if you were trying to look at the sun, but if you were able to look up with some special glasses, you might have been able to see a small ring where the sun was, and it got really dark outside, and it got really quiet. That's the thing I remember. But that's one example of an eclipse, and so the eclipses are really about shadows, really about shadows. So since eclipses are about shadows, there's two parts of a shadow that we need to be able to talk about. We need to be able to talk about the umbra and something called the penumbra. So here in our picture, here we have a bowling pin and a light source, which is no different than, say, light source the sun and either the moon or the earth, making a shadow out into space, but it's a little easier to see here. So the umbra is going to be this dark part of the shadow. It's the inner part of a shadow. Now, it doesn't really, it's really hard to observe this here, but I want you to know that the umbra gets smaller the farther it gets from the sun. So the shadow will get smaller the further it gets from the sun. You can kind of see that down here in this diagram. So here is an example. Here's our sun, our earth, our moon, and this reddish part in here, this is showing us the umbra. Notice how it's like a cone. It's getting smaller, okay? The other part of the shadow is something called a penumbra. Okay, so that's this outer portion here. Notice that it is lighter, and the penumbra actually is going to be, you can see that it is bigger than the bowling pin here. Well, notice down here as well, here's our penumbra, and notice that our penumbra is a cone that gets bigger the further away from the the object creating the shadow that it gets. So two parts of a shadow, the umbra, the darker inner part, and the penumbra, the lighter outer part. So we need to deal a little bit with something called total and partial eclipses. Most of our energy is going to be on total eclipses because there are many different parts of many different types of partial eclipses. So let's look first at a total eclipse. So a total eclipse is a type of eclipse that is going to happen when the object that's moving into a shadow moves completely into that umbra, meaning that dark part of the shadow. So if we look here, here's our sun, our light source. Here's the earth creating the shadow. And here is our moon. Notice how the moon is completely within the umbra. This is going to create something called a total eclipse. Okay. And for us to get a total eclipse, the sun, the earth, and the moon must be totally aligned. So this is caused by a total alignment. So you notice how everything here is in a straight line. Okay. Now, so that's a total eclipse. A partial eclipse, on the other hand, a partial eclipse is going to be when we don't have perfect alignment. So that means that in a partial eclipse, the object that is moving into the shadow only moves partly into the shadow, partial. So maybe it moves, and if we look here, we can see the moon has moved in only into the Earth's penumbra, that light shadow cone. And so that's going to cause a partial eclipse. Now, even if it just moved down here and it was partially in and partially out of the umbra, that also will only cause a partial eclipse. So this is not perfect alignment. So a total eclipse is a perfect alignment where the object that's moving into the shadow cone is going to be in the umbra. And with a partial eclipse, the object that is moving into the shadow is either going to move into the penumbra or only partially into the umbra. So let's take a moment to look at these two most important types of eclipses. First one I want to look at is the lunar eclipse. Now, lunar is a fancy word. It's a Latin word for moon. So a lunar eclipse is a type of eclipse that happens when the moon moves into the Earth's shadow. So that's what we've been looking at in our examples. So here we have our light source, the sun. Here we have the Earth. We can see the Earth has, once again, its umbra, the dark part, and the penumbra, the lighter part. But this is a lunar eclipse. So whenever the moon moves into the Earth's shadow, it's going to create a lunar eclipse. Lunar eclipses can only happen when you see this. Okay, so lunar eclipses can only happen during a full moon. Okay, so you'll never see a lunar eclipse happen if the moon was over here at a new moon or up here at a quarter, that first quarter, or down here at this last quarter. You'll never see a lunar eclipse, only at full moons. And during a total lunar eclipse, you're going to find the moon is going to look sort of a pinkish or a reddish color. Some of you may have experienced these before. We generally have 1 to 2 of these every year. If you've never seen one, I hope we can get you outside to check one out. So lunar eclipses are visible everywhere on Earth. So it doesn't matter if you can see the moon during a lunar eclipse, then you are going to be able to see the eclipse happen. Okay, and that's a little bit different. Now I do need you, this is an important diagram. I need you to pause this video and I need you to draw this diagram in your science notebook. So I want you to just draw the sun. I need you to draw the earth. I need you to make sure you draw the umbra and put a label on it, and then draw our moon in here. This is a very good drawing for a lunar eclipse. It's important that you be able to draw this yourself if you're to understand eclipses. So pause the video. When you're ready, move on. I may have already given this away, so we won't pause here. What does a lunar eclipse look like from Earth? Describe it. So this is an example of a total lunar eclipse. Remember I said the moon can look reddish or pinkish. This is an example, and I don't know if someone used a camera that had a filter on it to make this more red, or if there was more of that reddening effect. So some of you may say, wait a minute, if a total lunar eclipse is a shadow, then why is the moon turning red? Well, it's a very good question, and it's a pretty technical question that we're not going to spend a lot of time on. The simple answer is the same thing that causes sunsets, that makes the sky red sometimes at sunset, is the same thing that causes the moon to turn red. And it has to do with the light traveling through our atmosphere, changing colors. So light is made of lots of different colors, all the colors in the rainbow, but the red part of the light is the most powerful. And so sometimes our atmosphere will block some of those other colors, the oranges, the yellows, the blues, and the greens, but the red is able to continue on. And so the same thing that causes the clouds in the sky to turn red at a sunset is the same thing that would cause the moon to turn red here. You don't need to know precisely why it turns red, but feel free to do a quick Google search. I feel certain you'll find a video or something that will be able to answer that question for you if you're curious. So let's look at a solar eclipse, which is kind of that opposite of a lunar eclipse. And in a solar eclipse, this is the type of eclipse that happens when the moon moves into when the Earth moves into the moon shadow. So here's our alignment. Here's our light source, the sun. We can see that we have our moon, and the moon shadow. Here's our umbra for the moon. And notice here that the moon, because it is much smaller than Earth, notice that it has a very small shadow cone, and you can see that that cone is getting smaller as it gets further from the object. And so this has a big impact on what happens during a solar eclipse. Remember, the solar eclipse is what we experienced a couple of years ago. So I do want to point out that solar eclipses always happen in this alignment. Okay, so it's always going to be a perfect alignment where the moon, we're going to have sun, moon, and Earth. So during the total solar eclipse, the sun is going to be blocked, but only in particular locations. Solar eclipses are only very visible in really small areas on Earth. So you would have to see a solar eclipse when it happens. You would have to be directly here, right where that shadow is hitting the Earth. So solar eclipses are actually pretty rare for us to be able to experience. Like we could have a solar eclipse tomorrow, but if you didn't happen to live in a place where the solar eclipse was going to be visible from, where this shadow didn't pass over you, then you would not know that a solar eclipse had happened. It would be just like any other day for you. So solar eclipses always happen on a new moon, and it's where the sun is blocked out, appears to be blocked out by the moon. So you actually fall in the shadow. So I do want you to pause the video before we move on, and I want you to draw this diagram in your science notebook. It's a great diagram. Yes, I want you to include color. What does a solar eclipse look like from Earth? I want you to be able to describe it. Think about what you noticed if you watched the eclipse a couple of years ago, and then unpause your video. So solar eclipse. So here we have this dark disk here is actually the moon. Okay, so here's our moon. The sun is in behind it. And during a total solar eclipse, you would just be able to see some light would be kind of peeking from around the moon. But remember, it's a perfect alignment from where you're standing on Earth of the sun and the moon is blocking the sun. So I love this photo. This was taken from the International Space Station. This shows us it shows us the actual shadow of the moon on Earth during a total solar eclipse. So that means if you live here inside this shadow, you would look up and you would be able to see this. You would be able to see a total solar eclipse. If you live in here, you might see a partial solar eclipse. If you live over here, well away from these shadows, you might not know that there's an eclipse going on at all. So a total solar eclipse is very, very rare. If you ever get the opportunity to go outside and see one, you definitely should. Really a memorable experience. So when we talked about the tides, I showed you a tide chart. Well, I want to show you a chart, and I just went to the internet and typed in next eclipses. And you can see that it says featured eclipses in coming years. This is not all the eclipses that are going to be happening over the next couple of years. There are more than these. These are just the featured ones. But I want you to notice something here. June 21st, 2020, December 14th. So we have the eclipses and they're listed when they're going to happen. And we can see here, it shows us where these solar eclipses are going to be visible from. So if you happen to live in this area here for the red, that means that you would be able to see the eclipse. Okay, notice that we live here. We don't have anything out past 2026 for a solar eclipse. The most important thing for you to take from this particular image is that eclipses are very predictable. Once again, we understand the motions of the sun and the earth and the moon. We know when to expect a shadow from the moon to fall onto the earth. In other words, a solar eclipse. We know when Earth's shadow is going to fall on the moon, a lunar eclipse, and we can predict that. And you can with a very easy a with a very easy internet search, you can look up and see when the next eclipses are going to be. So eclipses are very predictable. These are known. Those motions are regular motions. All right, so here's going to be your assignment. I want you to, in your notebook, I want you to write definitions for these key vocabulary words. I want you to find eclipse, umbra, penumbra, lunar eclipse. Remember, you already have a diagram for this, but you need to get some words down, and solar eclipse. Remember, the whole point is you will be able to use your notebook on the quizzes. We got a quiz coming up soon. So pause the video, or excuse me, you're going to need to look back through the video and find these. Now, tonight I want you to continue. Hopefully we had clear skies last night, but I want you to go outside and see if you can spot a change in the moon. We will do this, we'll keep an eye on this on the moon and do some observations really for the next few weeks. So once again, go outside, see if you can spot some maria, some highlands, some craters. Definitely shade in the moon so that you can show what phase the moon was in, include that date and time. If it's cloudy, wait a couple of hours. If it stays cloudy, maybe try it again another night. So moon observation. So ladies and gents, I think that does it for now. And until next time, stay curious.